in ansys HFSS. In order for analytic derivatives to work, you first need a model that has been parameterized. In this case, we have parameterized the GPS patch antenna with permittivity values for the substrate, the dimensions of the patch, and also the feed location. The project variables can be accessed by going to the menu selection Project Variables. Here we can see all the variables that have been defined for this design. The next step in the process is to enable the solution to use those variables for analytic derivatives. So I right-click on Setup 1 and select Properties. From there I go to the Derivatives tab on the Driven Solution Setup. Here I can enable which variables I want to use for the analytic derivatives computation. So in our case, I'm going to use chamfer size, permittivity, the feed x and y, and the patch size as my variables for the analytic derivatives computation. I then select OK, and then I analyze the project. There are essentially two different ways to examine the outputs of an analytic derivative simulation. The first is to create a report with all the sensitivity information on one single graph. So to do that, we right-click on Results, Create Terminal Solution Data Report, Rectangular Plot. And I'm going to start by selecting the first sensitivity, and that is the derivative with respect to chamfer size. And what I'm going to do is I'm going to plot the partial of the magnitude of S11 with respect to chamfer size. And I'll click New Report and then Close. Here we're looking at that partial derivative of the magnitude of S11 with respect to chamfer size, and that is displayed across the frequency band of interest. Now, looking at this in and of itself, it doesn't give me a whole lot of information. But when I add the rest of the derivatives to the plot, we can see which variables are going to affect the S parameters the most. So I'll right-click on XY Plot 2 and Modify Report. From here, I will select Permittivity, add that trace. I will select the feed values, and finally I'll select the patch size and add that curve as well. So now what we're looking at is we're looking at a single plot with all the sensitivity information displayed. And in this case, what we see is that some of the variables, such as patch size, in the area of interest in the band that our antenna is designed to operate, the patch size moderately affects the S11. The feed positions affect it even less so. And the chamfer size is relatively small as well in terms of the sensitivity of the S11 to changes in the chamfer size. But we note that the highest sensitivity is with the permittivity. And so changes in material properties will make the greatest changes in S11 to our particular design. So by displaying all of these analytic derivatives on the same plot, we can essentially down select the variables that are most important to our given design. The second way to examine the output of an analytic derivative simulation is to actually tune the reports. And we're going by the notion that if we know the S11 versus frequency and we know derivatives that affect that S11, we can then come up with a new solution. So the first thing we have to do is we have to create a report based upon all the derivatives. So we go to Rectangular Plot, Derivative All, Tune Terminal S Parameter, Tune S11 All, New Report. And then we close this down. The next thing that you have to do is you would go to HFSS Results, Tune Reports. And this brings up a set of slider bars where we can adjust the values of each of the variables and see how they affect the total S11. So you can essentially tune your S11 based upon the variables and the sensitivity information. Now note that this tuning is based upon the single simulation and the sensitivity values. So those sensitivity values are based only upon small variations around the central design point. So be careful what you do with the tuning information that you get with this methodology. It's always best to apply those changes to the variables and run another HFSS simulation. One thing to note about the analytic derivatives function within HFSS, it is only available with the use of the Optometrics license in conjunction with ansys HFSS. For further information on this or any other capability within any ansys product, please contact ansys technical support. Thank you.